Well, hi everybody. I thought I'd do this question again for you so there was no confusion since we rushed through it today a little bit and I made a mistake in the end of this question. So here's the chart that we had set up, and we can see that we've got the P and the Q's in their different combinations, and the definition of P if and only if Q, which is this in this spot here, is it's true when both P and Q are true. It's true when both P and Q are false, but it's false in the two other places. So the idea is if and only if is that P holds exactly when Q holds and P doesn't hold exactly when Q doesn't hold. So those basically it ties P and Q together. So let's go through the table now and make sure we understand how that works. So the point I was trying to make here was that we can think about P if and only if Q as P implies Q and Q implies P. So those two columns, this column here and this column here, should be logically equivalent. So our definition of P implies Q is true when P and Q are both true, false when P is true and Q is false, and it's true whenever P is false. If we think about that going back the other way, so now Q is this thing called the antecedent. So we should say that at the beginning, the first thing is called the antecedent, and the second thing is called the consequent. So when we think about the Q as being the antecedent here instead of P, then we're going in the opposite direction. So here we're going Q is true implies P is true, so that's going to give us a true value for the implication. If Q is false, then it doesn't matter what P is, we define that to be true. If Q is true and it's followed by P is false, then that's a false value for the implication. And again, if we start off with the antecedent being false, it doesn't matter what follows. Here it's false. That's going to be true. Okay, so now we've got P implies Q and Q implies P. So I'm going to look at these two columns and I'm going to put them together with this and. So we've got true and true, so that should give us a true value for the conjunction. We've got false and true, so that should give us a false value for the conjunction. Again, true and false gives us a false value, and true gives us a true value for the conjunction. So now when we look at this column and this column, they should be the same. They are the same. So we say that P, if and only if Q, is logically equivalent to P implies Q and Q implies P. Okay, so this corresponds when you're thinking about an argument, starting at P and proving that Q is true, then going back and starting at Q and proving that P is true. So then you get a two-way sort of proof when you've got this if and only if statement. So I hope that little video clears up the error and the speed at which I did this morning. So enjoy.